Hello, let's talk about agentic techniques in retrieval-augmented generation with Azure AI search. I'm Maxim Salnikov. I'm based in Oslo, Norway, where I work at Microsoft, where I help developers to succeed with our cloud and AI technologies. I built on web technologies since late 90s of the last century, and I'm huge fan of the developer communities and conferences. And when I speak, train, blog, my favorite topics are web development, cloud development, and generative AI. To start with, let's have a quick conversation about how to build high quality search in applications that use large language models. Because there are well known limitations of LLMs. First of all, their public knowledge is outdated, they are always frozen in time. And for sure, they don't have any internal knowledge, any knowledge that your company obtains. To mitigate these limitations, there are two well-known techniques on how to actually incorporate domain knowledge. Fine-tuning, perfect technique, but could be quite expensive and takes some time to fine-tune the model, to rearrange the weights. Basically, we get another model as output. And another technique, maybe it's more popular, it's kind of mainstream for building LLM-infused applications, it's retrieval augmentation, when we inject these pieces of knowledge straight into the prompt. So basically, we let LLM learn new facts temporarily. Consider common RAG example. RAG, this is acronym for Retrieval Augmented Generation, involving user query about employee benefits. The query submitted to search engine, which then retrieves relevant document segments from pre-indexed collection. And then both original query and these retrieved segments sent to LLM with instructions to generate response based only on provided information and to include citations. The answer could look like that, and in many cases, for simple queries, that works just fine. For RAG application to perform efficiently, we need to have certain elements in place. First of all, capable LLM. LLM that adheres to instructions, and good idea to have the one that supports function calling. Then, well-prepared data is vital. Documents, for example, HR policy PDFs, like in our example, are typically processed by extracting information using tools, for example, like Azure Document Intelligence. Text divided into chunks, often around 500 tokens, optimized for sentence boundaries. And these chunks then converted into vector representations and stored in search index. And finally, powerful search functionality is crucial that supports both keyword search, vector search, hybrid search, and sophisticated semantic re-ranking. Azure AI Search is one of examples of these super powerful search engines. It's designed as search engine specifically optimized for RAG. It offers robust retrieval and integrated methods for bringing data into search service, facilitating RAG pipelines. It supports a variety of integrations like the ones with semantic kernel, LangChain, Llama Index, Azure OpenAI, Azure AI Foundry, and many more. And it also provides enterprise-ready framework encompassing security, compliance, and private networking features. And it gives us chance to build fully streamlined RAG data pipeline, ingesting, extracting, chunking, embedding, indexing, and querying data. And of course, it works amazingly well as a part of Azure AI Foundry project. Azure AI Foundry provides access to a range of models, including those from OpenAI, Mistral, Llama, and many more. And recently, Foundry Agent Service was introduced, offering managed service to support creation of AI agents. AI Foundry also includes various tools available for generative AI applications like Azure AI Search that we are talking about, Azure AI Vision, Machine Learning, Azure AI Content Safety, and Document Intelligence. And the overall goal of Azure AI Foundry is to offer a comprehensive set of capabilities, allowing for development both locally and within Azure production environment. And Azure Search Query Pipeline has continuously improved over the years, starting with keyword search, then adding vector search, query rewriting, and re-ranking. The process involves an L1 stage and L2. On L1, we perform query rewriting followed by parallel keyword and vector search. And these results then merged using hybrid search. On L2 stage, we take these merged results and re-rank them. To illustrate these stages, let's consider the query. What underwater activities can I do in the Bahamas? Parallel keyword and vector search are initiated. Keyword search might identify scuba diving in the Bahamas. Vector search, recognizing semantic connections, might return scuba diving in the Caribbean, because Bahamas are in Caribbean, and possibly kind of noise, water skiing in Seychelles. Then hybrid search intelligently merges these results, and after all, semantic ranker reorders them, prioritizing the most relevant results and removing potentially noisy ones. For example, the one with mentioning Seychelles. And this layered approach contributes by producing pertinent and accurate results. However, despite capabilities of existing RAG approaches, applications can sometimes encounter difficulties with complex queries that involve multiple embedded questions. For example, when we ask about some security patch providing this ID and which systems are these patch compatible with, and also like intentionally in this example it has typo. Or another example, what's the difference in costs for co-pays versus split pays. So maybe in that sense regular RAG engine is not enough. This is why we introduced Agentic Retrieval. And this is new feature designed to address these more complex query types. Agentic retrieval includes multiple new stages. First of all, query planning. The initial question is analyzed by LLM-powered query planner, which then breaks it down into more manageable sub-queries based on information required. Then parallel execution. These sub-queries executed simultaneously using the full search retrieval framework. And finally, result merging. The most relevant outcomes from each individual sub-query combined into a single comprehensive list ready to be used for the final answer. And another notable enhancement is that Azure AI Search can now process entire conversation history, not just the latest history. And of course, that supports query planning much better. Going back to this example with security patch, having full conversation history passed as input, of course, provides much better fix of the typos and provides much better content. And also now we can split queries into sub-queries to make sure that results are best of the best. But let's go back to our Northwind insurance example. Let's take the same question. What's included in my Northwind Health Plus plan that's not in standard? And then agentic retrieval supported by LLM formulates two sub-queries: plan benefits for Northwind Health Plus and plan benefits for standard Northwind Health. The key distinction is that results from both of these subqueries are then integrated. This approach facilitates more detailed and comparative answer, addressing this implicit complexity of original inquiry. And also, in multiple SDKs that we have for Azure AI Search and Azure AI Foundry, we introduced new component, Knowledge Agent, that is responsible for orchestrating query planning. This agent connects to LLM, processes conversation history, performs planning, executes parallel queries, and delivers results in two ways: as list of document references, similar to standard search results, and activity log, which transparently details query planner's actions, including cost and execution time metadata. A key aspect of the knowledge agent's functionality is its ability to consider the entire conversation history, not just the most recent message. This is highly beneficial as it enables agent to generate relevant subqueries even if the last question is not fully self-contained. For example, if a discussion has previously touched upon standard plan benefits and subsequent question is simply about payroll deductions for Northwind Health Plus, the agent uses the full context to understand the intent and plan accordingly. And transparency is super important, particularly when considering resource usage. The activity log provides detailed insights showing token consumption for query planning, both input and output, and it also provides metadata for generated queries, included the number of results and execution time for each, which can be super useful for analysis. And after all, how do we actually make sure that this agentic retrieval approach is better? Well, normally for RAG systems, we use three dimensions when evaluating. First of all, content relevance. Is content we are grounding on relevant for the question or conversation? Second, answer relevance. Content might have been relevant, but is the answer produced by the language model actually relevant? And third, groundedness. Is the answer based on the data we found and not hallucinated? And our evaluations suggest notable improvements with agentic retrieval. For complex queries where information is needed from multiple documents, we witnessed approximate 40% increase in answer relevance compared to standard RAG. Additionally, there have been about 30% improvement in answer rate, indicating that agentic retrieval can provide answers in scenarios where standard RAG might not. And for simpler queries, their performance remained comparable, suggesting no regressions. That is great. And agentic retrieval appears to be particularly beneficial for handling more complex information needs. And that proves the fact that agentic retrieval is super useful, super important. How can you try this in action and where can you learn about that? Here I provided a set of the links on guides and support materials on starting with Azure AI Search, starting with agentic retrieval in Azure AI Search, and a couple of quick samples for you to start very quickly. And last but not least, first of all, thank you very much for watching this session, and my main call to action: connect with me on LinkedIn. I can send you slide deck with all these links on your request after you message me on LinkedIn. Follow me. I post mainly about AI, about generative AI and Azure AI Foundry, and it's my great pleasure to present on this topic for your company, your team, and your conference. Thank you very much.